So I think what we wanted to do was walk through the announcement that we made last week, our joint effort together to create Project Monterey, and give you a little bit more detail. Obviously, it's very much open for Q&A. Vipin and I will sort of tag team on this one, and yeah, please don't hold back on your questions, and as I know you won't. So what is Project Monterey? Let me give you sort of some of the VMware background here as to how we came upon this. And so we came into this starting last year with our announcement of Project Pacific. Project Pacific was really focused on reimagining VMware Cloud Foundation to be this platform for modern applications. We're building in Kubernetes fundamentally into vSphere. And so, as we did that, and as we started seeing more and more these modern apps running there, what we realized was unless the hardware and the hardware architecture is also rethought, we're quickly going to run into a lot of problems. Scalability problems, performance problems, operational management problems, and so on and so forth. And so, this is really what spurred a lot of the thinking around what is now called Monterey. And working with Pensando became one of these things where we really realized how powerful the SmartNIC can be. That it can be this really foundational architectural change from a hardware perspective, and that it can drive benefits kind of across the board around performance, security, operations. And for us at VMware, it also offered this ability to enable us to support bare metal workloads inside of vSphere and VMware Cloud Foundation. So again, kind of mind-blowing stuff, right? And bringing in all of our consistent operational model across different locations, wherever customers need to run, we spend a lot of time getting VMware Cloud Foundation out to all these locations, and now we can bring them this great functionality with Monterey and sort of evolve in place their existing infrastructure. Overall, we believe reducing TCO and improving the ability to support modern apps. And Vipin, feel free to jump in anywhere here between each of these.
Certainly, please go ahead, Kit. I think we'll talk through things and maybe answer questions. That probably is the best way to have that conversation. Please go
I don't know if there's a chat window or how this works. If people are just going to yell them out, I know when we're in person, people just start yelling them out. So again, don't feel shy.
We're just going to keep yelling them out. That's how it works.
Perfect. Love it. All right, good. Keep us on our toes here.
Yes.
So, looking at it from a value prop standpoint, what do we really see here? Well, the first thing that we're really excited about is being able to drive line rate performance, peak performance, especially as you get up to 40G, 100G type cards. It becomes increasingly difficult for us on the ESX, NSX side to be able to drive line rate there, and so leveraging the SmartNIC technology, we can now do that. And it actually is beneficial in numerous ways from a performance perspective. Increased bandwidth, decreased latency, decreased jitter, especially with a lot of the data path work that Pensando is doing, just some amazing possibilities there that we can take advantage of. So it's great for us as software folks when the hardware is so awesome. But then also, by moving all this I/O processing, I/O overhead off to the SmartNIC, what it allows us to do is to free up x86 cycles for the applications. And this is good for many, many reasons. This actually goes to that second point, making it operationally more simplistic, because now you don't need to factor that in, that kind of the I/O overhead in. You can actually have a simpler model for how to calculate how much available capacity there is for the applications there. But on the operations side as well, we can bring in bare metal servers sort of under the fold here, get some of the operational simplicity there. As we'll talk about, the lifecycle management aspect becomes dramatically improved here. There's a lot of really, really cool things that we can do with this newer architecture. And we think, overall, as I said, we can get significant reductions in total cost, and that being both for CapEx and for OpEx, actually. So some pretty exciting possibilities there. And then finally, on the security model, this whole notion of a traditional security perimeter is gone. I think we all understand that now. And that, applications are distributed. They're in the cloud, they're on-prem, they're at the edge, they're kind of all over. And so you really have to take into account and fully embrace a zero trust security model. And the only way to do that is fundamentally with the appropriate hardware primitives, right? Again, we operating as software can only do so much. We need this stuff rooted in hardware. And so what we have with Monterey and working with Pensando is this incredible ability to get that hardware level protection, but then to also offload a lot of the security analysis type activity that we would do traditionally on the x86 side onto the SmartNIC side. So you actually can get this great comprehensive security without any performance impact, right? Because you're doing it right there on the NIC in line with the network stream.
So I understand the words that you're saying, but then when I think about applications, I have a ton of questions. So at any part in the next 2 hours, are we going to see an architectural kind of diagram, how all of this actually fits and how we can how that, just how everything moves around and doesn't impact how I would deploy an application?
Yeah. I mean, yes, we have some diagrams. I mean, I don't know if they'll be detailed enough for you, but we can certainly talk through some of those questions. So yeah, let me get another slide or two in, and we'll start talking about that, because I think we do have a series of kind of builds on kind of how the ESX architecture changes and what that looks like, and sort of what the impact of the application is. The good news is that by and large, this is a very, very transparent change to the application. Now, over time, and I'm sure Vipin has a bunch of thoughts on this one too. We want to explore what can we do to actually enable applications to take advantage of these offload capabilities. Something in this space. So this is stuff we're just starting to think about, but the initial step will be very transparent to the application. Really, the benefits will be to the admin and to these new functionalities that we're talking about here.
Indeed. Let me chime in just a little bit more to what Kit mentioned. I think the theme has been acceleration, so I think that's really out of the park. You can get all these services at line rate and great, but there are applications who are maybe more latency sensitive, and there are applications who need more guaranteed I/O isolation from their noisy neighbors. There are applications who care more about arbitrating resources. That's really the hardware stuff that first bullet is really capturing. PCI emulation is a big deal at bare metal layer. That's what SmartNICs provide. PCI emulation can allow the ease of application use that you were asking the question on. Is it changing? For example, if I can emulate VMXNet 3 driver from VMware, then I don't need to change anything on my OS. I could simply go ahead and start doing PCI pass-through right into your current VMs without changing anything. So those kind of things gives you performance without changing any of the operational model. Same thing with NVMe emulation that comes with PCI emulation. That allows you to use remote storage as local block storage, which means you practically could go very high capacity down the road. Another point that SmartNIC devices bring really is the visibility and troubleshooting. That's also a very kind of slide-in kind of function. Day zero, you can start getting to know a lot of things that otherwise would have either impacted your applications from the performance latency point of view, or it would have altered maybe some of the behavior with respect to how you operationalize collecting that data. So that kind of comes in maybe more naturally there. Overall, I would say that SmartNICs are not built as a hard-coded ASICs or functions that are like baked and loaded. They are highly programmable, as Kit and I are going to talk through the architecture and details, but certainly we'll go through the operational aspects of deploying the applications and see if it is, how much is it impacting and how the deployment model looks like for applications end to end. Partnering with VMware for Pensando, I can say this is the biggest benefit to the user is that your operational model doesn't really change. You get to do things the way you are familiar with, but you get to take the advantage of what what public cloud is underneath providing to their tenants.
Mm-hmm. Yeah, very well said. And I think you kind of got to a bunch of this kind of middle bucket here of operations and simplified operations. Like there's so much goodness here that we can bring together with Monterey, and this notion of like an API into the hardware almost. It gets really, really interesting, as we'll talk about. It's like really powerful and kind of mind blowing actually. So I think honestly, Vipin was just talking to us. I was like, man, I really need to make this bullet more emblematic of kind of the power of this, because I don't think it fully captures it. Okay. So big reveal, big surprise. How are we doing this? Well, we're leveraging SmartNICs. That's really all this slide was there for. The breakout session is not quite as obvious, but here everyone kind of knows what's going on. Again, though, we've really been on this journey over the past 3 or so years, I would say, of really rethinking VMware Cloud Foundation. And, we started with Project Pacific, as I mentioned, getting Kubernetes in there, TKG. And now this comes along with Monterey as kind of that second step to support sort of the bottom half, if you will, of VCF, and really thinking about hardware architecture, cluster architecture. So let's talk about that. Now, Vipin is way more of an expert on this than I am, so he'll go into a lot more detail. But let me give you kind of the really simple, kind of high-level capabilities here. So, of what distinguishes a SmartNIC from a regular NIC, right? And we talked about a lot of these. So, independent management operations here that we have, and essentially the core thing, of course, is that there is a general purpose CPU complex on the card, like essential, like a server here on the card. And as Vipin mentioned, it's extremely programmable. Obviously, a general purpose CPU, very programmable, but the accelerator aspect and everything Pensando is doing with P4 and really driving that and amazing performance on this data path here for high performance offload. And so this goes to all types of I/O. We talk a lot about network, and that's clearly a big focus, probably the initial focus for a lot of our customers and use cases. But we want to do that for storage as well, since everything's going to be passing through the NIC. We think there's a huge opportunity, and of course, security, as I mentioned before. And as Vipin was just discussing, this ability for this card to expose virtual PCI devices, virtual devices on the PCI bus, it's really, really powerful. And again, starts giving us this amazing API, if you will, into this hardware functionality. Yeah. So please, Vipin, continue.
No, I think you're capturing the essence of this thing. Overall, I would say is that if I were to summarize it, how public cloud infrastructure is managed is through the network, because it allows you to automate the services deployment without having to touch anything that applications or the tenants are using. In that sense, for public cloud, those are tenants. But it allows network manageability of a compute unit, including the services that are sitting just next to the applications in the compute unit. And if you just peek beneath the layer at which you are renting VMs and renting bare metal in the cloud, this is the layer that starts building the infrastructure in public cloud, wherein the intelligent entity is sitting right next to your virtualized workload or a bare metal workload or even container workload for that matter. And then it has enough power to be able to make it seamless for you to deploy various services that are being offered as security groups, that are being offered as load balancers, that are being offered as virtualized EBS kind of block storage, that are being offered as, from the infrastructure point of view, as flow logs and telemetry and AI and all these other services. And that's the layer that we are starting to talk about. So tip of the iceberg is what you see in the tenant. Underneath this kind of infrastructure architecturally is what exists. And happy to talk about why ARM cores are needed versus what exactly is DPU, how much can go in there versus the CPU path. But I'll drive it through the questions. I really want you guys to ask the hard questions.
So this is really the hardware foundation that we on the VMware side are building off of. And again, it's some really foundational, critical components here. So let's talk about how this actually works with ESX. So this is today's world, or maybe yesterday's world now, with this announcement. And no surprises here, right? Very overly simplistic, but hopefully this captures the essence of it. So what we're doing here is moving to a SmartNIC architecture, which means that because we have this general purpose CPU, we can actually move a lot of the things that used to happen on the core x86 side, core server x86, into the SmartNIC. Now, concretely, we are actually running another instance of ESX on this server in the SmartNIC. And in fact, if you had like 2 or 3 SmartNICs, we might have 2 or 3 instances of ESX in addition to the main one, well, not the main one, the one running on the x86 server side. So this is kind of the blue versus green ESX here. So we do literally have 2 different full copies of ESX, like 2 identical separate copies And as you can see, we start getting a lot of flexibility on what we can run where. And as I mentioned, it makes a lot of sense to run vSAN, NSX, which both provides networking and security services, as well as host management. So the storage and network and security ones, I think, are pretty straightforward. We've already talked about those. We understand this idea of offload. If you look back at that previous slide, there's kind of a fast path versus slow path. We can run a lot of this on the general purpose CPU, the ARM CPU that's there. But as much as possible, we want to take advantage of the fast path. And so there's a bunch of work we're doing to offload that and to drive even greater performance. What's kind of new in terms of the last few slides that's interesting here is the host management box. So essentially what we're doing is having the ESXi that runs on the SmartNIC manage the x86 server. So why is this powerful? Well, this is powerful because essentially now the ESX on the SmartNIC becomes kind of the bootstrap that we can spin this one up first, and then use it to actually start the ESX on the x86. And then that blue ESX can kind of manage the green ESX, so to speak. And so we can now start treating ESX, the green one at least, kind of like a VM a little bit. We have an image for it. We can PXE boot it, get it up and going. That's great. If we can do that for ESX, it means we can do it for bare metal servers as well, right? Essentially, we have this, it's not virtualization, right? It's just leveraging these hardware capabilities, but it's kind of like virtualization that you can manage an OS image. We can provision that onto the x86 side here and boot it up, all that. And then we can expose a variety of virtualized devices. Now, again, the virtualization is happening at the hardware level.
Right.
This is the Pensando card exposing, what appears to be to the x86 server, real physical hardware devices. And this is the beauty, and maybe, Vipin, you should talk about how exactly this works and go into some more detail. But essentially, through those devices, we can expose vSAN, NSX, etc. functionality.
Right. Hey, Kit, I have a question about the portion in the graphic where it says security air gap.
Okay.
Since they're both attached to the same physical piece of hardware, I mean, the SmartNIC is slotted into a slot on the physical server. Where does the air gap come into that? Because when I think of an air gap, I think of two systems that literally have no physical connections between each other. And this is not that. So where's the air gap?
Well, yeah, there's not a physical air gap. You're right. But essentially, what we have here is this kind of defense in depth that the stuff running on the x86 side, either Windows, Linux, ESX, what have you, is not aware that any of this stuff is happening. So it's the same sort of model that we have with virtualization. It's a hardware enforced separation model,
right?
That we have here.
I mean,
so you're correct that, like, in a purist security air gap term, that is not correct. I think it's trying to get across the concept that there is this extra level of security and isolation that's present there. So yeah, we can fix that to be more accurate.
Right.
Not that anybody would ever be pedantic on Tech Field Day.
That's good, man. Well, I had gotten wind of this late last week as someone else was saying, hey, I heard this feedback. So it's good feedback. And I think you're right. So we need to get crisper on that one.
So I need kindergarten explanation here because I still don't understand, right? So ESXi has a footprint, and then when you layer on NSX and you layer on vSAN, especially, that footprint grows and grows and grows. So are you saying that entire footprint can be on the SmartNIC? Are you saying, I don't understand, like, what is where? That's throwing me a lot.
Yeah. So I think, first of all, this diagram here may not be specific. We might not run all of them on the same SmartNIC. But these SmartNICs are, as Vipin can talk about, they're pretty beefy nowadays, right? Yeah. Lots of ARM cores, lots of memory. So this can run ESX. It can run all these things. Now, has this all been perfectly fleshed out? No, like, this is directionally where we want to go. And so it may be the case you have two SmartNICs, one for vSAN, one for NSX. I'm not exactly sure.
Yeah,
but Vipin can talk more about the specifics.
Let me give you some sense of why we believe it can be all in one card. And it might sound crazy, but we talked about performance and we talked about putting things into the data path and all that. It comes very handy to free up the CPU to do only control plane functions on those ARM cores and do only the manageability aspect of things. So yes, I think we have actually put all these things onto a card working. So I can say that with full confidence that you can put these things in the card. With VMware, we are not there yet as a solution. So that's what we are trying to be a little bit, saying that, okay, this will come out. But the confidence of having ability to do it is guaranteed there, and we can definitely work on and show a demonstration on that one. The reason we believe we could do it with less number of CPUs is because, let's say you have 8 to 16 cores dedicated for ESX. I mean, there are 16 ARM cores on the card. And you are offloading most of the data path functions into the data path unit, which kind of is 80% of the CPU and memory consumptions on the card, which leaves 20% of that to be done on ARM cores. Can we do it? Absolutely, we can. And is that how public cloud does it? That's exactly how they do it. So we think that, it is certainly possible. For bare metal workloads, actually, you don't have a choice. You have to do it there. The virtualization starts at the bare metal layer, so you have to do it there.
Okay. I have questions about being able to see it, like, coming from a traditional vSphere point of view, right? A traditional VMware point of view, like, there's definitely questions about licensing. I don't know if you're going to get into that, and definitely questions about, like, do I manage this with vCenters or something else that manages all? How do I see what's going on from a low-level operations point of view?
Yeah, let me talk through that second. The first one, the licensing, we haven't gotten to like a pricing and packaging discussion or any of that yet. Like, what we announced last week was really the tech preview, and again, working between ourselves and Pensando, we can prove out that this can work. As Vipin mentioned, there's a lot of work to do to get to a GA solution. Part of that, obviously, is pricing and packaging. So, not there yet. Now, to your second question, or the second part of your question, though, on the manageability. So this is actually really, really interesting. Essentially, we have two options for how to expose this. But by the way, all options can be or will be through vCenter, because that's how people manage stuff. But the real question is, do you want to manage two ESX instances separately, or do you want to manage these two as one? So we actually want to support both these use cases because we think they're both great for different types of users and situations. So in the case where you want to have just basically a single kind of logical ESX host, even there may be two ESX instances, would be perhaps a traditional enterprise customer who really wants to take advantage of offload and network offload, get high performance, this sort of stuff. But they don't want to deal with the nitty-gritty of having two ESXs and figuring out all that sort of stuff. They want to see one in their vCenter screen and just kind of deal with it like they did before. And it's kind of, the stuff is just kind of invisible. It's just a great performance benefit and so forth, right? We think there's a lot of good use cases there. Now, there's also a lot of good use cases to manage them separately. The first one would be if you want to have some bare metal and some ESX, right? So there you want to manage that blue ESX. That's kind of your the infrastructure provider type of view, and then the green ESX or the Linux would be kind of a tenant type of view, as Vipin was mentioned before. This is kind of like the public cloud model. And you can imagine doing, like having a CSP or something use this to enable bare metal as a service. There's other sorts of things as we'll get into. You get into more interesting type of cluster architectures where you might want to have, again, both these things managed explicitly. So we're going to work on both of those management models, and we just think that there's different ones for different use cases there. But it is, to your question, going through vCenter. This is vCenter, and again, well, I don't have any demos here. If you look at the breakout session, we show a couple of demos that will show what vCenter actually looks like when you're looking at this. They just look like ESX hosts, right? A few differences, but by and large, the same, tooling, same skill set, all the same stuff you do before you can apply here.
Basically, I mean, when you talk about such things in front of techies, their minds start to go into overdrive, right? So yeah, as of today, we can run ARM onto a Raspberry Pi. So I'm pretty sure that this card can run multiple copies of it. So I ask you this, for example, the dual BIOS motherboards, where you can upgrade one BIOS and then just do a reboot and switch to that. Can we do the same thing with ESX then? Have multiple copies, upgrade it to another ESXi version, do a reboot, and ESXi is running a newer version. If it doesn't run, you fail back. Something like that?
Yeah, so that's kind of where the lifecycle management comes in. And this is still an area that we're exploring, and it's going to take a number of things that we've got to align. But yeah, so first things first is that we want to be able to independently manage both sides here, both the x86 side and the SmartNIC side. We're looking at various sorts of motherboard designs that will allow the SmartNIC to have an independent power supply, independent power cycle from the main board x86 processors, which means we can power cycle them separately. We can do that sort of stuff. We could bring up the SmartNIC one first. In cases where you have multiple SmartNICs, you could actually have, it's kind of like almost an active type of thing. You could bring down one of the ESXs and upgrade it without impacting any of your data flows, networking, storage, etc. So there's definitely some really interesting things we can start doing here from a lifecycle management standpoint, and we think dramatic simplifications, dramatic improvements that will allow for continued uptime and less kind of interruption from these sorts of things. And I don't know if you have any thoughts on this one. You want to add?
I want to answer the question straightforward. Yes, you can switch between the boot images. That is certainly possible. In fact, you can do better than that, which is like after you boot the images, all services which are being executed, there are stateful services which are maintained here. I mean, there's no reason for us to not switch over to a new incarnation of the software, which has newer functionality with least disruption as well, and that's quite powerful, even just in one card. But what Kit was saying was that you might want hardware redundancy, in which case you have two cards, and yeah, sure, you can synchronize the state that way. But it's certainly possible to not only switch between the images or decide on which image to boot versus not, and do the switch over. But soon after switch over, you have to maintain and preserve the state so that it is seamless to the applications which are running. They don't even know that upgrades have happened. And how often it happens that in public cloud, you're notified that, hey, we are going to upgrade, so please shut down your applications. Never happens. So we envision that kind of infrastructure down the road where you get the experience of, and in order to do that, technically, you require a ton of things to be done. And which is why I think having an ARM complex that has intelligence that can coordinate all these things is very crucial, which is why the brains need to be in the card so that you can coordinate these things, switch over the things, maintain the state, quiet the pipelines, have enough memory and CPU, especially not CPU, but have enough memory so that you can have an alternate state that you can switch over to. All those things are very valid and part of this solution.
Yeah, that's exactly what I was getting at. So yeah, we'll be excited to see that whenever that happens.
Definitely.
Right. Thanks.
Okay. So that's the transformation that we're talking about here. And again, it's kind of like the fundamental sort of architecture of having multiple, or at least two now, ESXi instances and sort of the different responsibilities of each one. Okay, so what then gets more interesting is when we start looking at this from a cluster point of view. So here we have a cluster, let's say of 4 hosts, each with a SmartNIC, and then we're assuming some sort of high-speed interconnect here, PCI type or CXL type, what have you. Now, in a traditional world, when you have an application, it obviously is using the physical resources from its local host, right? No, nothing surprising there. But once we start leveraging this ability to disaggregate and then recompose, what we can do is start remoting these hardware devices to different servers that need them for their applications.
Right.
So let's talk about what's happening here. So essentially, as we mentioned before, this SmartNIC can expose on the PCI bus a hardware device, a virtual hardware device. And so if we know that there's one, make it look to the local host as if there really is a local FPGA, let's say, when in reality it's got to send all the instructions to that FPGA to a remote host. Well, that's fine. ESX from an x86 side thinks it's a real FPGA, can pass it through to the application, which thinks it's a real FPGA. But in reality, the SmartNICs are really orchestrating this. And so I think what gets really interesting here is it kind of changes fundamentally this traditional HCI type of architecture where we don't need every host to be identical. We can have different hosts within a cluster have different sets of hardware capabilities, hardware accelerators, storage, etc., right? And so it can be a very heterogeneous type of configuration. And applications can start wherever they want, and that's fine. And we can sort of compose that server with the hardware needed for the app on the fly based on what that app needs. And so it makes things really, really dynamic and allows for a lot more flexibility. And flexibility in things like scaling. You don't need to like add more CPU just to add more storage. You can add just more storage, right? And that's okay. So I think it really opens the doors on a lot of this flexibility and agility, while at the same time maintaining a lot of the operational simplicity, which was the whole reason for HCI in the first place. But Vipin, please take it away here.
You're bringing up a very interesting point. This, I think, what this enables really is the brownfield incremental adoption, as opposed to take it all or leave it kind of situation. So you can start off with devices that don't have SmartNICs, and then roll it out as you go. But indeed, the concept that you are primarily talking about, Kit, here is really hardware as a service from the infrastructure that is completely orchestrated through VMware is very attractive, because that's if you can get 10x benefit for computing certain things, be it like accelerating something, or be it some AI application or something equivalent, ultimately it's going to translate into lower capex and lower opex. Sometimes we have had the calculations where these devices can pay for itself just based on the power savings they give you for what they are saving in the regular CPUs. And when we talk about the savings, it's not just the CPU cost, it's the memory and the entire server footprint, which is what you are trying to optimize, and then cooling costs associated with that. So it can offer that leverage, and the leverage is possible because this device can project itself to the server as if it's locally available. So there's no change to the software stack on the kernel and up. But underneath, I think it is pulling all these resources in a very transparent way. And that's really the power of an example of this could be a storage from other device could be exposed as an NVMe local drive on server one. And server one doesn't even know that it's not local. And you can resize that dynamically to say that, no, I want to increase it from other pool and all that. So that's really, I think, hardware as a service concept that Kit is talking about.
Will this technology also work with Bitfusion? Because that's something Bitfusion does already. So will it work with Bitfusion?
Yeah, it's complementary. I think so. It's interesting, right? Bitfusion versus what we're talking about here are complementary, but they're actually focused on a little bit different use cases. So first of all, Bitfusion is specific to GPUs, right? But it's kind of more open in terms of network architecture. It can go kind of wherever, and remote a GPU potentially over distance, although performance issues obviously there. Mm-hmm. But it's kind of higher level, right? Because we're interposing at the CUDA API level. Okay. This is a bit different because here what we're doing is it's really a hardware abstraction, a hardware virtualization, for lack of a better term, as I mentioned. So it's more general in the sense that it can support any sort of hardware device. Anything on the PCI bus, that's fine. I mean, we're focusing on accelerators here, things like storage, like those sorts of things, but whatever else comes along. And Vipin, you can correct me here, but I think they're probably more, because it's at the PCI bus, there's going to be more restrictions in terms of latency. So you're probably going to be, this technology here is really focused on a single physical cluster within a data center or some fault domain. So it's got a bit more not limited, but just more focused there. So that's kind of the trade-off. Bitfusion, just for GPUs, but you get a bit more choice in sort of network topology. This technology is much more generic in terms of supporting all sorts of different hardware devices, accelerators, but you need to have a bit tighter latency restrictions. I mean, Vipin, does that make sense to you?
Yeah, no, it does. It does. At the same time, we have actually seen use cases where these devices sit in remote branches and other locations like small offices, mm-hmm. For SD-WAN kind of things perfectly well, because you really don't need to leverage the resources, but having a control point that exists in every compute unit is what is powerful about this architecture. So you don't need to decouple the compute unit from having to put another infrastructure that sits alongside that to manage and use it. So I would say that there are use cases where clearly there's applicability outside data center, but when you talk about like heavy, data heavy pooling of resources that requires lowest possible latencies, absolutely you're right. That I wouldn't recommend putting it over a WAN link for sure. But at the same time, we could actually implement sophisticated mechanisms to ensure that it works over any IP network. So you don't need to change your network just because you want to use this architecture. You continue with the standard network, you continue with the standard OS and the applications. This layer is going to start to allow the infrastructure to be used, in that case, more efficiently and present it on different nodes.
Yeah. Yeah, no, thank you. I think that's a good point too. And you're right. I mean, I think, and as we'll talk about here in a second, the SmartNIC technology is, absolutely applicable at the edge, and a lot of these things that we're talking about can be there as well. Yeah, and I think to your second point, Vipin, I was talking about the connectivity aspect, and it's an interesting one. You can do it over IP. So anyway, there's a lot of, as we're kind of brainstorming here, a lot of interesting directions to take this. But Gina, back to your question. Look, I think, what we're doing here. I think maybe the other distinction between this and Bitfusion is that Bitfusion can be used for, this is very server-to-server type use cases. Bitfusion could be server-to-server, maybe server-to-client as well. So, look, I think there's different ways of solving these problems, and I think what we have here is a really, really powerful thing. It does some of the Bitfusion stuff, but it also does so many other things as well. So this is just one point of where they're doing similar things, but there's also highly complementary in pretty much every other way. So,
since we're talking about a programmable NIC, my concern, of course, is with security, right? Anything that can be programmed can be compromised. And since you write in the packet stream, that is like the crown jewel, right? Once I own the NIC, then anything else in terms of security around it is pointless because I can modify the packet. So how is the concept there to really secure as much as possible so it doesn't get compromised?
Mm-hmm. So let me take that. So we talked about the boot process. The security, there are multiple aspects of the securing. The first thing is that, what can go on the card and the access to the card itself. So card needs to be FIPS compliant device so that it can authenticate the keys from anyone who's trying to access it. But that also helps where a card comes in born with a manufacturing key that can authenticate the software that gets loaded onto the card, and any program subsequently, like the whole bootstrapping of the boot layer and the kernel, and then the applications and anything that runs on it can be 100% authenticated. In fact, we think that because this is a separate unit and not part of your regular kernel, and we talk about this air gap thing. And I'll describe a little bit more about how that prevention happens for any compromise that may be happening at the Linux kernel level in the host operating system or Windows or anything else. The OS vulnerabilities, how we decouple that. The OS which is running on the card is super tight, very tightly controlled, as opposed to a general purpose OS which may have tens of packages running onto them. It's controlled with the source code. It's not like we are packaging in general purpose binaries into it. So from source code, we compile that code, stamp it to make sure it is the only thing that can run on it, and then bootstrap the entire software stack that runs on it, and then back it up with the manufactured hardware key that ensures that no unauthenticated software can run on the card. So that's like just booting up a software and running the authenticated software on it. And then comes what are the entry points into this device that could manage or control it. Clearly, I think there is 100% prevention, hardware-based security. This is exactly how public cloud does it. You cannot penetrate through public cloud by renting a VM in and get into AWS infrastructure, like for example. So it's kind of that level of hardware-based security, guaranteed security, and we challenge people to break that, to be honest. So there is nothing you can come in from the host if you are renting a bare metal, for example. Even if you have hypervisor layer, there is no entry point. This is network managed or the infrastructure managed device. So entry point from the host is 100% secure. We can definitely back that. Coming in from the network, booting up the image is highly secure based on the mechanisms I described. Certainly a topic of a detailed discussion on how that bootstrapping happens. But all said, this is exactly how, for example, I would imagine Titan IC would do for Google servers or something equivalent. Then the third part is access into this device itself. The way the bootstrapping works and the way the card goes and presents itself to the control plane is guaranteed to assert its identity, which means that during admission time, you can guarantee that the card is claiming to be whoever it is. And if I were to guess, that maybe that's exactly how edge cloud deployment with anything would work, where if you can assert the identity of a device first, and then you can admit that, and once you admit that, and then it becomes part of cluster, you have a secure channel established at that point without exchanging private keys, which means that now you can open up the card to be managed by an authenticated device. So we think that we have covered all three aspects of the security of making sure that this device itself cannot be compromised. And you're absolutely correct that if you get access into this, hell breaks loose. Of course, which is why I think it is built with a security level of what public cloud infrastructure would be like. And in that sense, you can always quarantine certain devices and all that. From the point of view of compromise of the host itself, a card itself doesn't have any more access than what a kernel has on the host. But yeah, I don't know if it answers your question. But
no, it does. Thank you. The only follow-up question is, the card is supposed to be upgradable, I assume, in case you find vulnerabilities and you get spectered, for example, so you can upload new code.
You can certainly upload the new code. You can certainly upload new data path pipeline, which is huge. Let's say I found vulnerability in something that is running on the I'm not providing security to applications as accurately as I thought, so I want to fix that. So data path pipeline upgrade, and then applications which are running in the on-course upgrade, and the best one is the kernel upgrade itself. And we are living in the era where kernel upgrades need to happen on the fly, and so yes, certainly that is using exec kind of mechanism. We could do that.
How is this going to be available in the VMware portfolio? We're talking 1 year, 2 years, 3 years. And is this only going to be VMware Cloud Foundation, or is this going to be a more general?
Yeah, so what we announced last week was just the tech preview, as I mentioned. So we're not talking about any timelines yet, but we are obviously working hard, and we have working code, so that's always a good thing. I think a lot of it goes back to actually what Vipin mentioned, which was, how do we really create a usable solution for customers that kind of works end to end, has all the right security things we just talked about, all the other, operational, et cetera, considerations. So that's really where we are. But again, we can't talk about timelines yet. And the same with pricing, packaging, et cetera. Technically, this works just fine with just vSphere. But, we do think there's a lot of value in the NSX side and vSAN side being there. And so VCF is a natural, point for that, right? So again, not making any decisions or anything, announcements here one way or the other, but it's definitely something that we're looking at and would love to hear feedback from everyone. So that's kind of where we are right now.
Yeah.
Question about who this is for. I can see certainly a use for it in, say, public cloud or service providers, but do you see uses for it with customers outside of those kind of people who are providing this as a generic service at a certain level of scale to a lot of people on a kind of rent it and be fairly ephemeral basis?
Like a CSP use case, you're saying?
Well, outside of that, so I can see a service provider providing this in that I want to be able to sell service to people. They may not actually want it for more than a month. Rent it. I want to be able to connect in a GPU or a TPU or something, use that, run a bunch of workloads, then shut it down. And it's easier for me to manage, and I can do that at scale. But it's so for clouds and service providers who are used to doing that kind of thing and want to make the investment in knowing how to do that, I can see that being useful. I'm not really seeing a lot of use for it outside of that, say into enterprise or the bulk of what VMware's traditional customer base would be.
Well, so let's see. I don't know. I think I talked specifically about verticals or segments or sectors that might use this, but kind of our view is that you're right, in the sense that there's a lot of the obvious ones, telcos, large financials, CSPs, those are the ones that are kind of interested in this initially. The initial use case is really around network performance. That's really what's hitting a lot of people right now. They need to drive line rate from these much faster networks. Want to reduce overhead, reduce costs, etc. So that's kind of the one that's getting us in the door in a lot of these conversations against financials, telcos. Now, security is another one that comes up a lot, actually, as we were just talking about. We talked to financials about that, and there's different sorts of aspects there. I think, in this, you can see some of these other use cases here, but I think what you're going to see is that this absolutely will trickle down, if you will, and to mid-market and then, smaller customers. Look, I think this ability to get the sort of hardware flexibility that we're talking about, to be able to share hardware devices seamlessly, any type of hardware device, is really, really powerful. I think the operational simplicity that comes out of this is huge. And again, while it may take a little while for especially some of the smaller ones, these increases in network speed are real, and so you do need the right sort of underlying hardware architecture. What I see fundamentally is that this just becomes part of the architecture. It's like initially we kind of have to sell this to people because it's like a new thing, but eventually it's just the way you do it, right? And again, we think that this thing actually saves you money from both a CapEx and OpEx standpoint over time. And there's a bunch of more analysis to do there, but that's kind of our initial viewpoint. So I think where we're going with this is that the SmartNIC just becomes a core building block of VMware Cloud Foundation, and it's like core to how we operate and how customers use the software. That's where actually I see this going over time.
So, Kit, I want to add to what you mentioned. When we talk to customers, they give us their use cases, and to your point, that there is this insertion point that never existed, where they want to be able to do simple things like wiretapping, bidirectional, at line rate. They can't do it today. Visibility on what's going on. They have to install something here, something there. Maybe they get that through one way or the other. But it's always good to, like one customer we were talking to was like, is it a network problem? Is it a server problem? And that's always a question. This is the point that can tell you where, because it knows what came in, what went to the network, what was received from the network, what was sent to the application, what came back from application, back to the network, and reverse. So the telemetry, troubleshooting, visibility is a very interesting use case that has been brought up quite heavily. And when I say telemetry, troubleshooting, and data collection, it's not just for visualization and all that. It is as much security, point that you can bring back to the game and improve the overall security posture. So that's the second use case where people who don't care about performance and high scale and cloud-like bare metal deployment, they are perfect for encryption use cases. Like I'm a regulated industry and I want to turn on encryption inside my data center. I don't want things to be going naked on the wire at all. How do you do that without sacrificing your cores? Well, this is the entry point, which can just with a knob turn these things on. Visibility troubleshooting, improved metrics can give you more better security posture calculation. And of course, you have products that can ingest this information. And certainly we are working with VMware to integrate that. Those are like additional ones. So security and visibility are two additional use cases that we see besides performance and storage related use cases. But then, like Kit mentioned, this is flexible thing. You can add more things to it tomorrow. If it becomes part of infrastructure, then you have a chance to tweak and enable those services as you go.
Say, for example, 2-3 years down the line, this technology is available, and apart from service providers, enterprises start looking into that. But by that time, at that point, they may not have them in their service. So is this something that at that point, an enterprise can say, my servers are end of life or at end of performance, if you like, and add this card so to reclaim some of that performance back and then extend the lifetime of their service? Is that a use case that you're looking into as well? Do you see customers doing that?
It's a very interesting point, actually. We think it could extend the life. At the same time, we also don't believe that operationally people actually take out a card from a server, which is exactly why we're partnering with HPE and Dell and server vendors to make sure that it is seamless experience for the user to acquire the cards and RMA them. There's one point of contact if something were to go wrong. Those kind of things are super important for end users. So is it a PCI card? Absolutely. Can you plug it into your server? Absolutely, you can. Would that be the normal operation that I hear from customers? Not so much, largely because their the way of acquiring servers and retiring servers doesn't fit that model. But if you want to be greedy and go that route, go for it. Absolutely, why not?
Yeah, I think I hadn't thought about that. It's an interesting use case. I think, where we were thinking about it is like, look, to Vipin's point, it's really VMware, Pensando, and then the server OEMs working together to create a unified offering, right? And so you can imagine this, that, VMware today, we have the different sorts of like VxRail, let's say, with Dell, or servers that are designed specifically for VCF. And so you imagine that as we go forward there, those things will increasingly have SmartNICs as part of their BOMs. And you look at what we're doing with Dimension, or VMware Cloud on Dell. There, it's like a cloud service on-prem, and we're absolutely going to be taking advantage of SmartNICs there because, again, all the operational benefits. So I just see this like these initial customer conversations, you absolutely need to justify this new thing coming in and kind of think through all the implications of it. But over time, I think as the industry really revolves around this, and we start moving this up at scale on-prem, you're going to find just becomes a standard is the direction we see it going. And again, just because of all the benefits across the board, CapEx and OpEx, we want to embrace this, build it in.
I have a question about the Pensando architecture and how it interacts with the rest of the motherboard. Traditionally, a lot of things you're talking about from the control plane would be handled through a BMC port.
Correct.
But it sounds like, to a certain degree, you're thinking of moving that port onto the SmartNIC. Is that the intent, or would you still have a BMC port on the server and then a separate management port for the SmartNIC?
So port will be same, but the manageability will be through that interface. So we don't. Today people use single wire that goes into the server, and we want to keep that assumption because they are not going to duplicate their top of racks or create additional infrastructure to add more links into their infrastructure. And we recognize that challenge quite heavily. And there may be some DMZ kind of cases where people don't want to do in-band management of the server. And that's a choice they have, which is why the card has an option to be managed out of band, but that's not the only way you do it. So that's like managing card, but then managing server can also be bundled into the same interface. So we are not replacing BMC. There are a lot of tools that implements Redfish APIs to manage the BMC layer. We are not replacing that. We are just facilitating that to be done through this common, interface that people don't have to look at it like, oh, for card, do I need to have one more port? And then for server, another one, for BMC, another one. It will bloat things and maybe create more problems for people. Again, having talked to customers, them giving us feedback, we are triaging on this kind of thing where we have to work cohesively in the industry to make sure that it doesn't come off as a negative thing from the operational point of view, because otherwise it's not going to fly, in my opinion.
Right. When I think about the control plane, you mentioned the one thing I wanted to ask about, which was Redfish and support for Redfish to manage some of the SmartNIC components. But your control plane and RESTful interface overall, how open are those, and do they associate with existing standards that are out there?
Yeah, so I think we are, I can speak for Pensando here. So what we are doing is we are working in the community, we are working in P4 community and other community to ensure that the APIs that come out of the SmartNIC is standard. Having said that, the VMware integration is going to be leveraging those things almost internally because you are consuming the entire service at a much higher layer. So you don't see that standardized part of it. But certainly from Pensando's point of view, we are actually also talking about the architecture to be open. Ideally, if we get if our vision comes true, then there will be people who will be writing applications on these devices, data path applications on these devices, which is not Pensando. Like in this case, VMware is writing it, but you could have someone else write the applications on this platform. So we are providing the substrate where people can decouple how services get deployed this layer to be independent of people who are supplying the hardware to run these applications. And these applications are like network and storage, any infrastructure services, telemetry, security, those things.
Okay, yeah, because I'm thinking of something like OpenStack that might want to take advantage of these Pensando cards as well, and having a standardized and open API for all the SmartNICs would be nice. Maybe it's a pipe dream, but it would be really nice to have that standard that all these different providers could hook into.
Correct. Now, OpenStack uses OVS as the data plane function, and I did talk about these cards being programmable and flexible, and I want to stick to that point and say that yes, it can actually have that. If OpenStack, if I were to compare, maybe Kubernetes is a bigger priority for us than OpenStack, but can it implement an OVS DB going into the card so that it is plugging into the to the ecosystem? Absolutely can. So I would say that kind of interface exists. Rather than reinventing something, I would plug into that. But is there is there a thing that exists that can take the data path to its fullest extent? OpenStack is still an offload model based on OpenFlow, and that's why I want to differentiate between offload and subsume. Those are two different things. When I offload, I still have a bulk of software running in somewhere that takes advantage of the hardware. And that maybe you can do with today's cards also in one way or the other. And the beauty of DPUs or SmartNIC devices or domain-specific processors like Pensando's device is that it can subsume the entire thing, which means you can have a VF directly going into a VM, dropping into the card, programmed by VMware that can take entire functionality out of the software path. And that's really is what is attractive here. So I would say the difference between offload and subsume, if we go with traditional model of, let's say, OpenStack or something, it will be offload model. But I'm not saying it's a bad thing. All I'm saying, it will give you the operational compatibility with what exists against the raw power of the card, which you're not tapping into today. But you can always do that over the period of time.